So here's an example of this problem, and it's similar to the one that you asked me about. And what I'm going to do is let's see, I've got this building. They're on top of a 150-foot building, and they see some car that, let's see, it's moving towards her. So here's the car, okay, and it's driving this way. And at one point in time, Flora looks out, and here's the angle of depression. This is the part that people forget. That's 18 degrees. Now, sometimes they'll throw 18 degrees and 30 minutes into the mix, and then you got to remember how to change decimal degree or DMS notation to decimal degrees notation, and remember that in 1 degree there are 60 minutes. So I'm going to have to divide that by 60. If that were the case, I would write this as 18.5 degrees, but that's not what's happening here, so we won't include that in the mix. So then, and of course we've got this triangle going on. Then it tells me a few minutes later, she looks down at the car again, and that angle is 42 degrees. And they want to know how far does the car travel. So what we're looking for is this distance right there. So the big picture thinking is if I can find this distance and then find this distance and subtract them, that would be the green distance that I want. So a couple of ways to do this. From geometry, you may remember that this 18-degree angle and this angle down here are alternate interior angles, which means they're congruent. So that's 18 degrees also. And I've got this opposite side, which is 150 feet. So I'm looking for this long side, which would be the adjacent side. So I'm seeing an opposite and adjacent. This is the opposite of the 18-degree angle, and that big long side is the adjacent of that angle. So I'm going to use the tangent ratio. So that gives me this, that first triangle gives me this situation, and then I can say, because this is the opposite side, this is the adjacent side, I know that's the same as the tangent ratio, and the tangent of 18 degrees equals 150 over x. And we're going to treat this like a proportion. So that means I can do the cross products. I can say x times the tan of 18 equals 150 times 1. So x equals 150 divided by the tangent of 18, whatever that is, whatever decimal number that is. And that gives me that big long side. So then the second triangle that gets formed, remember this is the 42-degree angle of depression. This is still 150 feet. This is a new unknown side. If that angle's 42 degrees, this angle's 42 degrees, which gives me another opposite over adjacent tangent ratio. So I can say the tan of 42 equals 150 over x. I can treat the tan of 42 as tan of 42 over 1. Remember, the tangent of 42 is some decimal. And then I can do my cross products, and the same deal kind of works out. I won't show all those steps. It's 150 divided by the tangent of 42, and that'll tell me that shorter side. So now if we go back and look at our original drawing, so here's this original drawing with all the calculations we just did filled in, and so basically I know this side is equal to that relationship, or that decimal, whatever that is, and this whole side is equal to that part. So to find how far did the vehicle travel, which is that x, that green line, we're just going to take this larger number minus the smaller number, and that'll be how long that side is. Hopefully that'll help you solve this equation, or solve that problem now.